A thriving koi pond is a masterpiece of tranquility, but the vibrant health of your fish and the crystal clear quality of the water depend entirely on one unsung hero, the filter. For koi keepers, selecting a truly good filter is not a luxury, it is a necessity, directly impacting the biological balance that keeps expensive, beautiful fish alive. These intelligent creatures produce a significant waste load, demanding a filtration system robust enough to handle both mechanical debris and vital biological processing. Navigating the options, from pressurized and gravity-fed to advanced drum filters, can be daunting. Yet understanding the core principles of effective filtration is the first, crucial step toward maintaining your aquatic paradise. Understanding the three pillars of koi filtration: mechanical, biological, and UV. Effective koi pond filtration is a complex process, yet it can be simplified by understanding the three distinct and indispensable pillars that work in concert: mechanical, biological, and ultraviolet UV treatment. Each pillar addresses a different challenge in maintaining a healthy aquatic environment, and the failure of any one can compromise the entire system. Mechanical filtration serves as the pond's first line of defense. Its primary function is the physical removal of coarse and fine suspended debris, such as uneaten food, fish waste solids, and organic matter like leaves and detritus. Removing this visible gunk is crucial because it prevents the solids from decomposing and overloading the biological filter with excess nutrients. Media for this stage often includes filter mats, sponges, or advanced systems like bead or drum filters. When mechanical filtration is robust, it protects the next stage from becoming clogged and maintains high flow rates. The second and most vital pillar for fish health is biological filtration. Koi, being large and metabolically active, produce significant amounts of toxic waste, primarily ammonia. The biological filter provides an optimal surface area using media like bioballs, volcanic stone, or specialized mats for massive colonies of nitrifying beneficial bacteria to colonize. These bacteria are the engine of the crucial nitrogen cycle. They consume the toxic ammonia, converting it first into nitrite and then into the much less harmful compound nitrate, which can then be safely managed through water changes and aquatic plants. Without this process, ammonia would quickly poison the expensive and sensitive fish. Finally, the UV clarifier is the pillar that ensures crystal clear water. While not directly involved in removing physical solids or toxic nitrogen compounds, the UV unit passes pond water over an ultraviolet bulb to sterilize single-celled, free-floating algae that cause the unsightly green water phenomenon. This intense light destroys the algae's DNA, preventing its replication and causing it to clump together so it can be captured by the mechanical filter. A well-designed filtration system integrates all three pillars to provide a complete solution: clean, healthy, and clear water. Choosing the right filter size, pond volume, and fish load considerations. The fundamental health and clarity of your pond are directly proportional to the size and efficiency of your filtration system, with two primary variables dictating the correct capacity: the pond's volume and the fish load. While manufacturers rate filters for a specific gallon or liter volume, this rating is often for a lightly stocked, ornamental water garden, not a heavily loaded koi pond. As a rule of thumb for koi, a high-value species that grows large and produces significant waste, you should select a filter rated for at least 1.5 to 2 times the actual volume of your pond, effectively doubling the stated capacity for safety. The necessity for oversizing is rooted in the fish load, which represents the total bioload of waste from all inhabitants. Koi are substantial fish, and the accepted stocking density is often cited at around 250 gallons of water per adult fish. This heavy concentration of aquatic life generates an immense amount of solid and dissolved organic waste. An undersized system will quickly become overwhelmed, leading to frequent maintenance and, critically, a breakdown in the nitrogen cycle. A heavy fish load challenges each of the three pillars of filtration. The mechanical filter must cope with a massive increase in physical solids and sludge, requiring greater surface area to prevent clogging. Concurrently, the biological filter requires a significantly larger media volume to house enough nitrifying bacteria to process the proportionately higher levels of toxic ammonia and nitrite. Finally, even the UV clarifier may need a higher wattage or longer contact time to counteract the rapid proliferation of free-floating algae fueled by the excess nitrates in the water. Therefore, the decision is not simply about matching gallons, it's about investing in enough reserve capacity to handle a thriving, fast-growing, and well-fed koi population, ensuring stable, pristine water conditions year-round. In-depth look at mechanical filtration options, screens, sieves, and skimmers. Mechanical filtration is the crucial first line of defense in a high-load koi pond, directly impacting the overall system's efficiency by removing physical waste before it can break down and challenge the biological filter. The initial stage begins with skimmers, which operate as mechanical pre-filters by actively sweeping the pond's surface to capture floating debris like leaves, pollen, and uneaten food before they can sink and decay. This proactive surface cleaning significantly reduces the organic load entering the main filter system. For superior solids removal, particularly for the high volumes of fish waste and sludge produced by a dense koi population, specialized filters utilizing fine screens and sieves are indispensable. The most advanced systems, such as sieve filters and rotary drum filters, RDFs, rely on precision-engineered mesh screens, often sized between 200 and 300 microns, 0.2 to 0.3 millimeters. This incredibly fine level of filtration captures suspended solids that would easily pass through traditional filter pads, directly preventing the buildup of sludge and the clogging of biological media. A sieve filter passes pond water over a curved stationary sieve, where gravity separates the water from the collected solids, which then slide into a waste chamber. The rotary drum filter, RDF, takes this concept further, employing a cylindrical screen that rotates as water passes through. When the screen begins to clog, a pressure sensor triggers a backwash cycle, spraying clean water to flush the accumulated debris, providing fully automated and continuous self-cleaning mechanical filtration. Implementing these high-efficiency screens and sieves is vital to managing the massive solid waste challenge of a thriving koi pond, ensuring the biological stage remains clean, oxygenated, and maximally efficient.
The role of biological filters and media in the nitrogen cycle. The biological filter is the indispensable core of a successful koi pond, serving as the primary site for the nitrification stage of the nitrogen cycle. This natural process is essential for converting the highly toxic waste products of koi, chiefly ammonia, into progressively safer compounds. Fish excretion and decaying organic matter release ammonia, NH3, a substance lethal to aquatic life even in minute concentrations. The biological media provides a vast protected surface area for the colonization of two critical types of chemoautotrophic bacteria. The first group, primarily Nitrosomonas species, metabolizes the ammonia, oxidizing it into the equally harmful compound nitrite, NO2-. Subsequently, the second group of bacteria, Nitrobacter species, takes over, converting the nitrite into nitrate, NO3-, a far less toxic end product that can be safely managed through water changes and aquatic plant uptake. This two-step conversion is the biological filter's mission, transforming the pond from a toxic soup into a balanced ecosystem. The effectiveness of this biological stage hinges entirely on the specialized filter media. Materials such as high-density ceramic, plastic, or foam are engineered to possess an enormous internal and external surface area, often referred to as specific surface area, to accommodate the largest possible colony of beneficial bacteria. A larger bacterial population translates directly to a faster, more robust conversion rate, which is necessary to handle the heavy bioload of a thriving koi pond. As noted in the preceding section, the efficiency of biological filtration is entirely dependent on effective mechanical pre-filtration. By using high-efficiency screens and sieves, such as rotary drum filters, RDFs, to remove suspended solids, the biological media is prevented from clotting,
ensuring maximum oxygen transfer and sustained bacterial health. A clean, oxygenated biofilter is, therefore, the key to maintaining water quality and the health of the entire koi population. Comparing gravity-fed versus pump-fed filter system configurations. The configuration of a high-quality koi pond filter system fundamentally divides into two main architectures, gravity-fed and pump-fed, each dictating the system's layout, efficiency, and maintenance profile. In a pump-fed system, the submersible or external pump is positioned before the mechanical and biological filtration stages. This pump draws water directly from the pond, pushes it up to the filter, which must be located above the pond's waterline for the water to return via gravity, and then through the media. The primary and most significant drawback of this setup, especially for koi ponds, is that the pump's impeller can chop large organic debris and solid waste into smaller, suspended particles, known as fines. These fines are notoriously difficult for subsequent mechanical filters to trap, increasing the potential for them to bypass the media, or worse, prematurely clog the fine pores of the biological filter, reducing oxygen transfer and bacterial performance. Conversely, a gravity-fed system is the industry standard for serious koi keepers. Here, water flows by gravity from the pond's bottom drains and skimmers directly into the first mechanical pre-filter, like an RDF, located at or below the pond's water level. This ensures solid waste remains intact and is removed before encountering any pump. The pump is then positioned after all filtration stages, moving clean, polished water back to the pond. This configuration avoids the debris mincing issue entirely, maximizing the efficiency of the mechanical prefiltration. Furthermore, the pump in a gravity-fed setup operates under less head pressure, as it only needs to push water over the lip of the pond, leading to generally better flow rates and lower long-term energy consumption for the same turnover rate, compared to a pump-fed system, forcing water through the dense resistance of filter media. For optimal performance, particularly when integrating high-efficiency pre-filters like rotary drum filters, RDFs, the gravity-fed model offers superior maintenance access and maximum effectiveness against the heavy bioload of a thriving koi ecosystem. High-efficiency filtration. The advantages of rotating drum filters. The rotating drum filter, RDF, represents a significant leap in mechanical pre-filtration, offering a level of efficiency and automation that is unmatched by traditional settlement chambers or brush filters. At its core, an RDF utilizes a finely woven mesh screen, typically between 20 to 70 microns, encased within a rotating drum. This high-precision filtration capability allows the unit to capture even the smallest suspended solids, including fine fish waste, uneaten food particles, and pond debris, ensuring crystal clear water. This efficiency is maximized within the gravity-fed setup. By capturing solid waste before it can decompose or be pulverized by a pump, the RDF removes the nutrient source for algae and pathogens entirely from the system at the earliest possible stage. This critical function drastically reduces the organic load that would otherwise choke and overwhelm the subsequent biological filtration media, allowing the biofilter to focus solely on converting dissolved nitrogenous waste. The true advantage of the RDF, however, is its automated and continuous operation. As water passes through the mesh, trapped solids gradually clog the screen, causing the water level inside the drum to drop. A sensor detects this drop and triggers an automatic backwashing cycle. High-pressure jets spray the trapped waste from the rotating mesh into a waste tray, which is then flushed out of the system. This self-cleaning process ensures consistent flow, eliminates the manual, messy maintenance associated with conventional mechanical filters, and prevents the buildup of organic matter that can lead to anaerobic conditions. The result is a system that maintains optimal water quality with minimal intervention and maximum effectiveness, a necessity for managing the heavy bioload of a flourishing koi pond. The necessity of UV clarifiers and sterilizers for algae control. Even the most effective mechanical and biological filtration systems can be overwhelmed by the rapid proliferation of single-celled planktonic algae, which manifests as the dreaded green water. This microscopic algae competes with beneficial bacteria for nutrients and sunlight, obscuring the view of the valuable koi and impacting the pond's aesthetic appeal. For the koi pond keeper, an ultraviolet UV unit is one of the most powerful and necessary weapons against this common problem. A UV unit works by passing the pond water through a chamber containing an ultraviolet C (UVC) bulb. As the algae-laden water flows past the bulb, the UV radiation disrupts the single-celled algae's DNA, effectively sterilizing it and preventing its reproduction. Once destroyed, the now-dead algae cells clump together, becoming large enough to be efficiently captured and removed by the preceding mechanical filtration media, such as an RDF or a bead filter. This continuous process ensures crystal clear water without the need for chemical algicides. It is important to understand the functional difference between a UV clarifier and a UV sterilizer, which is often determined by the flow rate of water through the unit. A UV clarifier is sized for a faster flow rate, providing the necessary UVC dose to simply kill the single-celled algae for water clarity. A UV sterilizer, conversely, utilizes a much slower flow rate, increasing the water's dwell time under the UVC light. This higher, sustained dose is potent enough to neutralize other waterborne pathogens, including bacteria and viruses, thereby offering a crucial layer of disease control in addition to algae removal. For a heavily stocked koi pond where water quality and fish health are paramount, choosing a unit that functions as a UV sterilizer provides the ultimate defense against both unsightly green water and microbial threats. Reviewing common filter types: pressure filters, box filters, and bog filters. Selecting the appropriate mechanical and biological filtration is paramount to maintaining a healthy environment for koi, and common systems fall into three main categories: pressure, box, and bog filters. Pressure filters, also known as canister filters, are sealed units that rely on a pump to force water through the filter media under pressure, often containing both sponges for mechanical filtration and media for biological breakdown, sometimes including an integrated UV clarifier. They are popular for their ability to be partially buried and for directing clean water uphill, making them discreet and flexible for landscaping. However, while efficient for smaller to medium-sized ponds, pressure filters can struggle to effectively manage the substantial solid waste load of a large, heavily stocked koi pond, potentially leading to organic buildup if not diligently maintained. Box filters, typically larger, punk-fed or gravity-fed multi-chamber units, are a step up in capacity and maintenance ease for dedicated koi keeping. These often use a weir or overflow system and contain multiple stages of filtration, starting with mechanical screening, followed by extensive biological media in separate chambers. The larger volume allows for more media and longer retention time, which is beneficial for nitrogen cycle efficiency, though they generally require a dedicated space above the water level for gravity return models. Simple submersible box filters are suitable only for very small ponds, while robust, multi-stage external units can handle much higher waste loads than their pressure counterparts. Finally, bog filters offer a highly natural, aesthetically pleasing solution by utilizing aquatic plants, gravel, and beneficial bacteria as the primary filtration mechanism. They function by channeling pond water through a planted area, where the plants absorb excess nitrates and other pollutants, acting as a natural polishing stage. Bog filters excel at nutrient removal and can be low maintenance and budget-friendly once established. However, for ponds with a high density of large koi, which generate a significant amount of solid waste, a bog filter alone is usually insufficient. They are best implemented as a supplemental, ecological layer in addition to a robust mechanical and biological filter to handle the heavy demands of a true koi habitat. Essential filter maintenance and cleaning practices for optimal health. Consistent and correct filter maintenance is the cornerstone of a healthy koi pond, directly impacting water quality and the vitality of your fish. The necessary practices vary significantly across the different filtration stages. Mechanical filtration is the primary defense against solid waste and requires the most frequent attention. Filter mats, sponges, and brushes must be cleaned every 1 to 4 weeks during the warmer months, as this is when fish activity and waste production peak. The goal is to prevent clogging, which reduces water flow and can lead to anaerobic conditions. Regular backwashing for pressure filters or rinsing of media for gravity units is essential to remove trapped sludge before it breaks down and pollutes the water. Furthermore, weekly cleaning of the skimmer basket prevents surface debris from sinking and overwhelming the main filter. Biological filtration requires a delicate touch. The bacteria-laden media, bioballs, ceramic rings, etc., should not be cleaned with the same frequency or vigor as mechanical media. Overcleaning or using chlorinated tap water will kill the beneficial bacteria that convert toxic ammonia and nitrite into harmless nitrate, crashing your nitrogen cycle and stressing your koi. Only clean the biological media when water flow is noticeably restricted, which is typically every 3 to 6 months. When you do clean, always rinse the media gently using a bucket of water drawn directly from the pond to preserve the bacterial colonies. Finally, even low-maintenance bog filters need upkeep to handle the high waste load of a koi habitat. While the plants absorb nutrients, excess solid waste, mulm, can accumulate in the gravel, potentially leading to anaerobic zones. For koi ponds, it is crucial to eliminate excess decaying matter, often achieved by flushing or draining the bog system, ideally through a dedicated undergravel drain, to maintain a clean ecological layer. Seasonal deep cleaning of the entire filter system, particularly in spring and autumn, prepares the pond for periods of high or low activity, ensuring peak performance year-round. Top-rated koi pond filter systems for different pond sizes, brands, and models. Selecting the right filtration system is the single most critical decision for maintaining a healthy koi habitat, as the filter's capacity must far exceed the pond's bioload. Reputable brands offer specialized units tailored to 3 primary pond size categories, utilizing different filtration technologies. For small to medium ponds, up to 3,000 gallons, with modest fish density, pressurized filters are popular due to their compact size and ability to be placed discreetly away from the pond's edge. The Pond H2O pressurized filter with UVC and the Aqua Ultraviolet Ultima 2 series are well-regarded options that combine mechanical debris trapping with a biological chamber, often incorporating a UV clarifier to combat green water algae. A slightly larger, reliable option is the OACE BioSmart 5000, a flow-through box filter that simplifies maintenance with cleaning indicators and sludge drains, making it suitable for koi ponds up to around 1,300 gallons. For medium to large ponds, 3,000 to 10,000 gallons, which house a significantly higher volume of waste, a multi-stage approach is essential. The industry-leading Evolution Aqua Nexus Plus is a preferred choice, engineered specifically for koi ponds and utilizing K1 microbiological media within its unique mechanical and biological chambers for highly efficient waste conversion. Alternatively, the dynamic Koi Pond Filter 65 offers a powerful bead filter solution designed to handle the heavy bioloads of ponds up to 10,000 gallons. The Easy Pro skid-mounted filtration system also targets this range, providing a complete, high-efficiency package with a pressurized bead filter and an external pump. For very large or heavily stocked koi ponds, 10,000 plus gallons, dedicated high-flow systems are mandatory. This often involves a sequential combination of components, beginning with a drum filter, like models from Q-Series or Synergy, for automated mechanical waste removal, followed by massive moving bed biological filters for maximum nitrification. For instance, the Bubble Bead Filter XS1000 is a heavy-duty model capable of filtering systems up to 20,000 gallons, providing deep mechanical and biological purification necessary to sustain prized large koi collections. When selecting any filter, it is always recommended to size up, aiming for a filter rated at least one size category higher than your pond's actual volume to ensure clear, healthy water under the high nutrient load of a koi environment. The selection of a good koi pond filter is intrinsically linked to the pond's volume and waste load. Smaller ponds benefit from reliable all-in-one units like the Aqua Ultraviolet Ultimate 2 or the OASE BioSmart 5000, which effectively combine mechanical and biological filtration, often with UVC. For medium to large ponds, 3,000 to 10,000 gallons, specialized multi-stage systems like the Evolution Aqua Nexus Plus or Dynamic Koi Pond Filter 65 are essential to manage the heavy bioload. Very large or heavily stocked ponds, 10,000 plus gallons, require a mandatory sequential setup, starting with an automated drum filter and followed by high-flow moving bed biological filters. Crucially, regardless of pond size, it is always recommended to size up the filter to at least one category higher than the pond's volume to ensure clear, healthy water for the koi environment.